Hello, so in today's video, we're going to look at parallel lines and perpendicular lines. So in the context of coordinate geometry. So we're going to look at the essentially the equations of a parallel line or parallel lines to a particular line, and also how we can get the equation of a perpendicular line to a given equation of a straight line. So the key thing to obviously just bear in mind before we do any work is obviously the difference between parallel and perpendicular lines. So a parallel line is essentially something like this in this first diagram here. So parallel lines are lines that have the same quote direction. So in other words, they have the same gradient. So the key point is that they have the same gradient. So parallel lines have the same gradient. So the same steepness. So the same sign. So if you've got a line with a positive gradient, then a parallel line must also have a positive gradient. And they have the same magnitude of gradient as well. So the gradient there, change in y there over change in x there, is the same as the change in y over the change in x there. So if I call that y1, y1, y2, x2. So change in y1 over change in x1 is the same as change in y2 over change in x2. So they're parallel lines. They've got the same gradient. Now, perpendicular lines form right angles. So we've got right angle there, right angle there, right angle there, right angle there. So they form a right angle. And we'll come on to how we can find the gradient of a perpendicular line in a minute. But yeah, just a summary. So parallel lines, they have the same gradient. So for example, these lines here, these equations here. So y equals minus 7 over 10x plus 100 is parallel to y equals minus 7 over 10x minus 71.782. So the key thing is that it doesn't really matter what the y-intercept is. So these y-intercepts can be anything, doesn't really matter. The key thing is that the gradients are exactly the same. So negative 7 over 2 and negative 7 over 2. So the gradients are the same. So the m value, we'll just call m for gradient, the m value is minus 7 over 2 in both cases. So they must be parallel. So that's how you can determine if two lines are parallel. If given the two equations of those lines, that's how you can do that. And in terms of perpendicular lines then, so let's say you've got an equation of a line, and let's say the gradient is m. So let's say you've got an equation y equals mx plus c, gradient is m. Then a perpendicular line must have the gradient minus 1 over m. So this is another term you may hear for this is the negative reciprocal. So negative reciprocal. Okay, so sorry, let me write that again, negative reciprocal. Okay, so if you want to find, if you've got an equation of a line and you want to find the gradient of the line perpendicular to it, you must do 1 over that gradient and then put a minus sign in front of it. So for example, if you've got an equation, just as an example down here, y equals 2x plus 1, and you want to find a perpendicular equation, so you just want to come up with any perpendicular equation that you like. It doesn't matter what the c value is, doesn't matter what the y-intercept is, could be like 100, but the gradient must be negative 1 over m. So the m value here we can see is 2, the gradient there is 2. So it must be the perpendicular line, an example of a perpendicular line could be minus 1 over 2x plus 100. Again, the c value there doesn't matter. We're only worried about the gradient. So that's how it works. So if we try and draw like a little sketch, we've got a gradient there of 2. Let's say your m value there is 2. The perpendicular gradient must be an m value of negative 1 over 2. Or if I make this even steeper, let's make this line even more steeper. Let's say something like an m value equals 10. Then your perpendicular gradient could be something like this, for example, passing through this y-intercept there with a gradient of negative 1 over 10. So the key thing is that this rule here, the negative reciprocal, that gradient there is the gradient of a perpendicular line to an equation with a gradient of m. So that's kind of how you can determine whether a line is perpendicular. So we've got a couple of examples here. So let's say you've got y equals 2x plus 7, and you've got another line, y equals 10, take away a half x. So these are perpendicular. Why? Because the m value here equals 2 for your first one, but the m value here equals negative 1 over 2, which is negative the negative reciprocal, so negative 1 over our original m value up here. So I just call this m1, I'll call this m2. So this is the negative reciprocal, so negative 1 over m1. So that's why these lines are certainly perpendicular. Now, how about these ones down here? So these two equations are not in the form y equals mx plus c, but let's change them into the form y equals mx plus c. So if we rearrange the first one to make y the subject of the formula, we get 10y equals minus 7x minus 1. Divide by 10, we get y equals minus 7 over 10, x minus 1 over 10. So that's our first equation. How about our second one? Again, make y subject to the formula. So add 7y to both sides. We get 7y is equal to 10x plus 20. Divide both sides by 7. We get y equals 10 over 7x plus 20 over 7. So why are these lines perpendicular? Well, the gradient here is negative 7 over 10. So negative 7 over 10. And the gradient down here, again, I call this gradient 1. And the gradient down here for equation number 2 is 10 over 7. So when you flip this first fraction upside down, you get 10 over 7. Well, negative 10 over 7. Put a minus sign in front of it, you get minus 10 over 7. Minus makes a plus, so you get 10 over 7. So what I'm trying to say is that negative 10 over 7 is the negative reciprocal. Sorry, negative 7 over 10 is the negative reciprocal of 10 over 7. So these fractions there are negative reciprocals of each other, so negative 1 over m1. So yeah, let's just make a note of this here, that this is negative 1 over the first gradient. So therefore these must be perpendicular lines because their gradients are negative reciprocals of each other, and that's how you can tell whether you've got a perpendicular line. Now let's look at this example here. So the question says, find the equation of the perpendicular bisector between two coordinates, 1, minus 5 and minus 6, 10. Okay, so this term here, perpendicular bisector, what does that mean? So perpendicular means, well, it's got to be perpendicular to the line connecting these two coordinates. So I've drawn a sketch here. So it's got to be perpendicular. So maybe it could be like this, it could be like that, it could be like that. But it's a bisector. So if you bisect something, you chop it in half, basically. So it's got to go through the midpoint between this coordinate, this minus 6, 10 coordinate, and also this second coordinate down here, or the first one in my sentence, 1, minus 5. So it's got to go through halfway across, and it's got to be perpendicular. So perhaps something like, perhaps something like this, where this is a right angle there. So you want to find the equation of this line. So the question is, what is the equation of this line there? That's our question. Okay, so step number 1 then, we need to actually find the gradient of the line connecting those 2 points. Once we get the gradient of this dotted line connecting these 2 coordinates, we can then use the negative reciprocal to get the gradient of our perpendicular line. Okay, so we've got coordinates 1, minus 5, minus 6, 10. So the gradient, let's just write it here. So gradient of line connecting, if I just call this coordinate A, and if I just call this coordinate B there, so gradient of line connecting A and B, so it's going to be, remember, change in Y over change in X. So that's your formula to find a gradient. So let's just do this on the next page. So we could go from minus 5 to 10. So our change in Y is 10, our second Y coordinate, take away our first one. So 10 take away minus 5. So our gradient is going to be 10 take away minus 5 on the top, and on the bottom, change in Y, so minus 6 take away 1. So minus 6 take away 1. And so what we get is we get 15 on the top, 10 minus 5 is 10 plus 5, which is 15, minus 6 minus 1, minus 7 on the bottom. So in other words, minus 15 over 7. So step 2 then, that's our gradient of the line connecting the points. We're interested in the perpendicular gradient, this perpendicular line. So therefore we can say that the perpendicular gradient, so perpendicular gradient must be the negative reciprocal of this gradient we just found. So flip that fraction upside down, put a minus sign in front of it. We're going to get negative 7 over 15, which is just positive 7 over 15. So we know that that is going to be our gradient. And so we know that the equation, so equation of perpendicular, I'm just going to use this, this notation here just means perpendicular. So equation of perpendicular bisector, so that must be y equals 7/15x plus a c value that we don't know yet. Okay, so again, it's a bisector. It chops these 2 points in half. It goes halfway between them. So we need to work out this midpoint value here, this m value. That's what we need to calculate. So how are we going to calculate the midpoint? So we actually did this in the previous video. We looked at how we calculated midpoints yesterday. So let's just write this here. So step 3, calculate midpoint. So calculate midpoint. So the midpoint between these 2 points, again, I'm just going to make my writing smaller. So the midpoint is the average of the 2 coordinates. So we've got, again, our coordinates, 1 and -5 and -6 and 10. So the average of our x coordinates, I just call it midpoint for MP, sorry, MP for midpoint. So the average of 1 and -6. So we're going to add 1 to -6, divide by 2. And the average of our y coordinates, -5 and 10. So -5 plus 10 divided by 2, so the average of those. And if we work that out, so 1 take away 6 is just -5. So we get -5/2 for our x coordinate, and -5 plus 10. Again, that would actually be, well, that'd be +5 this time. 10 take away 5 is 5. So 5/2 as our y value. So that's going to be our midpoint. So we've got the midpoint. We've got the coordinates of this point here, which will be -5/2 and 5/2. So now then, because we know the equation of the bisector is going to look something like this, and we know that this point lies on it. So let's just make a note of this, that this lies on the bisector. That means we can substitute this coordinate, this x value, and this y value into our formula to obtain this, the c value. So step 4 is to obtain c, and we do that again by substituting in the coordinates of our midpoint into our, sorry, let me just move this back up like that, into our equation there. So obtain c value. That's our next step. So just substitute x, y equal to -5/2 and 5/2 into our formula. So using this equation there, we get 5/2 equals 7/15 times by -5/2 plus c. This will leave us with 5/2 is equal to, okay, I mean, well, 5/15, we've got 5 there divided by 15 there. 5 divided by 15 is 1/3. So actually we'll get a -7/3 times 2, which will give us 6. So you've got -7/6 there plus c. So our c value must be 5/2 plus, add the 7/2 to both, sorry, 7/6 to both sides. We get 5/2 plus 7/6. And this is the same as 15/6 plus 7/6. Yeah, I'm just going to try my best to keep everything on the same page. And if we do this calculation, we shall get, so 15 plus 7, we got a common denominator of 6. 15 plus 7 gives us 22/6. We can simplify the fraction a little bit. That's 11/3. Okay, so we get a c value of 11/3. So therefore the equation of perpendicular bisector is going to be y equals 7/15x plus 11/3. So that would be our final answer. That would be the equation, again, of our perpendicular bisector. And yeah, that's exactly how we would find that that equation. Yeah, so the key point again is that parallel lines have exactly the same gradient. So parallel lines always have the same gradient. Doesn't matter what the y-intercept values are, they can be anything. As long as they have the same gradient, they're parallel. Perpendicular lines, the gradients are the negative reciprocals. So again, if this has a gradient of m, then this gradient here must be -1/m. So flip the number upside down and put a minus sign in front of it. That will be your gradient of your perpendicular line. So yeah, that's how we can use parallel and perpendicular lines to find equations of new lines such as perpendicular bisectors.